Hello, ma'am.
Yes.
I mean, there was a question related to what means potassium iodide and the mercury and with iodide.
Okay, okay. I
So,
shall come. I shall come to all the questions. So let me first discuss about the assignment one. That what are the general problem that I have seen, and then all of whatever you have in your mind, I mean, whatever you feel that it is not right or you couldn't understand that, let me know. Or if you suggest that, let me first listen to your uh, concepts. I mean queries. So what was your query?
ma'am, there was a question related in the question four, I think,
Yes, yes.
that potassium with iodide doesn't form a good complex, or the mercury with iodide forms a good complex like that thing.
It's not a complex. I mean,
But related to that thing, I think.
related to the. So the point is that, as I told you, so one thing I must say that it is not that you have not understood things or like this, but I can understand that you have not read, you people. I mean, not all of you, definitely, not read the textbook properly. So whenever I'm teaching something, it is sometimes not possible for me to tell you everything. So what is the purpose of the teaching is that, what are the important thing, or from where should you uh, get the information. This is so for this particular question. So if you remember that, the question, let me open the question. Okay, let me open the question. Can you see the question?
Yes, ma'am.
Okay, so the question was not that complex. I mean, right now, you people, you are telling that complex. So the K1 for HGI plus is greater than that for MGI plus, even though Mg2 plus has considerably higher charge density. So one of the concept that you have dealt with till your 12th or anything, then this soft, I mean soft, hard soft thing is fine. Now here, one of the major thing that you have, I mean, missed, that is the complex formation, right? When you are preparing the complex, once the, because you need the presence of iodine, right, when you are preparing the HgI plus or you are preparing the MgI plus. So once this HgI plus is formed, immediately it I mean joins with the I2, and then you get the complex formation HgI2, and that is the driving force. I mean, I have not given you the parameters. So if you get these parameters for this hard soft acid base, hard soft concept, then it is quite understandable that only this hard soft cannot support this K1, the higher K1. So the point is that when you are considering the complex, then only you should. I mean, so I have given as a part of the question. The answer is the hard soft concept, and for that reason we have given zero point 0.5 marks. But I mean, in future, please remember these things. I mean, all these K1s are not only hard and soft, and you have to look beyond that. And I mean, I just wanted to see that whether you could look beyond the existing concept of hard and soft, and for that reason this question has been given, right? Is it clear?
Yes, ma'am.
Okay, so anyone else has any particular question? Otherwise, I shall discuss the assignment one. with one question, 1, 2, 3, 4, that what is your problem and what is expected and when you will get the marks. I mean, we have given marks because it's the first assignment and you are not very well acquainted with the drawings and all these things. So let me start. Or if you have
Excuse
any
me,
one
ma'am.
of you have, yes.
Ma'am, from the question 4 that you have discussed, can we use the reduction potential concept to quantitatively determine K1 is greater than K1 for HGI is greater
No,
than
I mean,
MG?
what you are telling that that will only give you the value of k1, right? So if you get the value of k1, you do not have all this data. So if you want to do the calculation, my point is that if you calculate the value of k1 for both the system, and then you put, I mean, you do not have any such very quantitative assessment, but if you comparison and all these things, if you put this quantitative data for hard and soft pairing, then you cannot explain totally the I mean the higher k1 completely. Let's say k1 has a component for this has hard and soft thing, because hgi plus and mgi2 formation has the this concept of hard and soft. And once this form, it goes out of the system as hgi2, and as it is going out as hgi2, the Recitrians principle come into the picture, and then more formation. I mean, the k1 become, and this becomes stable. So in that way you have to look, I mean, whenever you get the question, you have to look beyond this. And let's say in NET or in your GRE or in your any exams, it comes like this, and you do not have any parameters as such, then you must put this point. Maybe, I mean, in that way you should put. I mean, is there any formation, complex formation possible or not? In that way, you have to, and as you have learned hard and soft, and as you have now, once you, I mean, this is the point that once all of you have seen the question, immediately you thought of that hard and soft. In that way, when after reading the coordination complex, after reading all the parameters, all these things, you have to think in that way, that once you see a question, then you must have the in your immediately it must come to your mind in that way, the what are the other approaches that it can be answered. I mean, when you are going to the higher classes and when you are see a problem, you must think in multiple parameters. You should approach a question from multiple parameters and what could be the possibilities, right? Your possibility is fine, but here you will end up with k1. Next,
Excuse
please.
me, ma'am.
Yes.
Ma'am, I have hello.
Yes, I can.
Ma'am, I have problem regarding delta and configuration determining that when we have to accept the means sometimes the diagram is as should means we have to accept as it is and sometimes we have to rotate and make it in that way. And how?
Which this octahedral.
Yes, ma'am. The
So this
delta and this notation.
is this related to assignment one or assignment two, or whatever? What is your specific question?
Assignment one ma'am, means delta the
Okay,
clockwise and
assignment one. I'm coming one by one, right? So let me start. Is it okay, or you want to? Any one of you? I have listened to your question. I shall come to this. Next. Okay, a general suggestion for all of you. Not, I mean, many of you have maintained that as you are going higher classes, you have a multiple difficulties. You will face difficulties in the question. So please do not write too much, because we really do not have that much patience that a two-line answers, if you put it in 2 pages, no one will read. That's the point. And in some cases, if the first paragraph or if in the first two lines you do not have the proper answer, you will get zero. I have not given here the zero, not me. Our TSA also helped, but we have tried to understand that whether your concept is right or not, and we have given the full marks. But please be cautious from the next assignment if you write beyond. I mean, yes, there are practices that sometimes you feel that let me write a little more. So two line may go to 5 line, but 2 lines cannot go to 20 lines. Is it clear? I mean, it must be clear that you are a science student. You are not pursuing a descriptive thing. It is not literature. I'm not demeaning literature or something, but description might be needed. But if your answers contain only description, I mean, yes, with the right answer, but with this, don't describe too much, please. I mean, whatever is needed, I shall tell you that whatever is needed. And I can see that some people have finished the assignment with, I mean, it depends on, of course, with their handwriting, but 5 pages and 6 pages is fantastic. I mean, people have written all the relevant information and then finish the assignment, right? And as I told you that you may discuss with your friends, you may ask, I mean, see any answers from Google, internet, or all these things, but you should not write whatever is there. I mean, two answers, I mean, from two of your friends, that's exactly same. And I thank you that yes, there are less than this. It is not that nobody has done this, but it is much less. Now the point is that when you have taken the answers from Google or internet, any site or anything, please try to understand that, I mean, they give it in a way whatever people understand directly in some way. But here, if you do it from your understanding, it will be much easier for you. I mean, you can in some cases, yes, it is free, and as you are doing assignment, you will see. I mean, that I know. But why don't you try to mix up with your understanding when you are drawing a complex? It will be easier for you. I mean, it will be much easier for you to understand the thing and think. I mean, let's say this question you get in the internet, when you are giving exams with a little time, offline exams, you will not get internet. So why don't you, I mean, this, for this purpose assignments are given, so that you can I mean, gauge your understanding from this. So let me start from here. So the first question was, the first question was, they explain why this cobalt TnCl2 and trans this thing. So almost all of you, probably all of you have got two in this question, but what is the main problem that I have encountered? That CONCl2 and cobalt TnCl2, you have not learned to draw things, right? So if you are drawing any octahedral thing, and if you want to, I mean, in some of your pages I have done this. So whenever you are doing, it is better to draw. Yes,
വേണ്ട എന്തിട്ട് കറി ഇവിടെ കറി വേണ്ടേ ഡ്രൈ ആവില്ലേ പുട്ടും പപ്പടം കഴിക്കുന്നത്
please switch, Ajit, please mute your. Okay, so it is better that you make a octahedral field. Try to understand. I mean, what is the consequence? Consequence is that all of you have tried to draw, but there is a huge difference if you do not maintain the covalency, right? So from octahedral, if you change the symmetry at all for your drawing, then maybe I shall give you bus. But if it is a gross change in the symmetry, then people will see what is the point of answering the question. The question is not at all, I mean, what it's trans sees, because it is almost changed. I mean, there is horrible writing. So it's better you just make the frame, right? And once you make the frame, it is easier for you to do it. So one of the concept is that when you are doing the cis trans, so as all of you have mostly, I mean almost all of you have given right answer, so you do it in that way. So then you join this Cl and Nn. Number two is that when you have En, so if you draw it like En, even then we have given marks. So if you draw it like En, then always you cannot show it. I mean, yes, you can show it this isomerism, but this is not the practice. So if you have En, then you have to draw this Nn. And as you can understand that this En is very easy. It is not that you have to remember all the ligands, and if the ligand structure is very difficult to understand, then generally it is given. It is given that this is the structure, and I mean from the structure you will easily understand what are the uh, atom from the ligand is relating to the metal. So then you just draw it like that, but please try to draw it in I mean when you are writing ethylene diamine. And yes, many of you, maybe 17 8 25 people have drawn this NN concept, right? So this much is that. So what are the answers? So what are the answer? Yes, some of you have written it all this, but you need this drawing. So you need the drawing. This is the one point of the answer. This is the structure. Otherwise, you will not understand. Yes, for both of them, you have to draw the mirror image, and only this point that one of them is superimposable. So to just to make it one of them is superimposable, another is not, that makes chiral and acrylate. That's all. Please don't write anything more. We don't need anything more. Clear? The second question. So I think it is clear. I am not going to see the chat or anything. So you can write. I shall go. I shall when I shall go back to this main page. You shall just write that question one is okay. That you write. I mean, at least some of you write so that I can understand. The second question. The second question is log K1, K2, K3. So what is the marks? You just see what is the marks. The marks is 1 and 1. So if it is 1 and 1, sorry for these problems. So okay, I think you have understood. So please, I don't need this. The how does it form this Niken En3 En1? Only if you, even if you want, you can only one equation you can write, and from that you just do it, because here I just need the overall formation constant. Nowhere it is written that you show how does it come. It is the BS third year course, and you really don't need, because you will have too much of questions. Here it is assignment, you are doing it at your home, then you are writing. You don't need. I mean, okay, fine. And for this you can see that there is a mixed answer, and yes, part of the answers is right, and mostly that uh, uh, you have, even if you have write only the term static hindrance, we have given marks, but you can, here you can write one or two lines, like once one of the en has come, then the two sides are occupied. So whenever the second en comes, it is the occupancy factor. Yes, it is also steric factor. And you please leave, is there 929. So this occupancy factor you have to write, and you please check you with your answer. So if you are not satisfied, you can come back, or you can talk to Aditra also about this. Now the third one. So third one, yes, many of you have written quite well. So what is necessary? Again, here you really don't need too much of explanation. Yes, 3 marks is there. So be very specific. So what? First you have to draw the structure. Structure for both. Right, both isomer. both isomer, and then you show the stretching and uh, stretching, asymmetric stretching, asymmetric and asymmetric stretching, symmetric, asymmetric, and then you for this you really you just don't need to assign these to the band. For that reason 3 marks has been given. Those who have done this got 3 marks. And here, because this is rationalize this data, this rationalize means that you can correlate, and it is very simple. I mean, some of you have done the has written the answer correct. I mean, I don't really don't get. I mean, it is whether it is that you have not uh, uh, given the proper concentration or what is, because when you have drawn the structure you have perfectly written what is symmetric and what is asymmetric with the arrow, all these things you have written perfectly, and when you come to the assignment of the bands you fail. But why? I mean, if you have understood the symmetric and asymmetric then you could easily do it, because only one in the isomerism only one band is there and it is quite easy to understand. So I really don't understand what is the point. So please be careful. I think that those who have done the mistake it was not careful, and I could understand from their answers, right? So please be careful, a little bit careful. You can do this. The fourth is explained. Okay, now here the main problem comes. This is the main the question. Okay, let me do this. So these two people have done, but some of you have done a peculiar thing that you have not considered CN. Instead of CN you have written BR2. I mean, from where? Either you are trying to get something for internet, or you are I mean, it the answer could be wrong or answer could be right. That is the different perspective. But people, there are 3 to 4 people who have written instead of CN they have put another 2 bromine, and the question becomes meaningless. So what is the point? I mean, why you have done this? I really don't know. And here only the what is the most likely structure. Even if you do not get give any explanation, you will get marks. That's it. I mean, only the most likely structure. Nobody has asked you for any explanation here. And even if you give explanation, just one line is fine. Don't write one page, right? So this one is mostly all of you have done right, and I shall come to the this question number 5 at the end. Okay, and this application of tris fat, those who have written that the tris fat is that it is not possible to identify the pure enantiomer, and then the tris fat makes an adduct, this adduct term and the diastereomer term, if it is there you have got 2. So if for anyone there is a mistake, please let us know. We have not done the addition, the total marks yet, because in some cases we may have missed something, and then we will do the total marks, right? And now here in the third one, see, if the first thing is that here the main problem that I shall tell you, that yes, it is the conjugate base you have drawn, fine. When you are drawing the structure, you are drawing the FAC and mar isomer, like has draw the structure. The concept is draw the structure. All of you have drawn the structure. All, I mean, probably, I mean, I if not, then I mean, out of 36, maybe 32 or 3 people have properly drawn. So when you are drawing the FACMAR structure, then why you have drawn it, the structure which generally we draw for the delta lambda isomer, because it is there is no nothing I cannot uh, uh, I mean deduct your marks. That's the point. I cannot deduct, because whatever the composition you write, we have to give you the marks. But the point is that why don't you try to understand that you don't need it. Today is a and people are coming. thought that anytime they can join. Okay, I am also admitting. So the point is that what is the point that mar fact mar when you are drawing and fact mark, if the question contain only fact mark, don't go to this propeller type of structure like here you have done. You have, I mean, most of you have done in that way. I mean, I can with this structure, but when you have fact mark, then this is the best way. So if you take here, here, and here, so you just give it like that. And what you can do, nobody has mostly people do not write this octahedral framework. And here, if you want, you can give it as a solid line, but please draw the framework, it will be easier. And then you give it as a dotted line. So if you do not give it, then it becomes very difficult. So you please draw the frame, and then you just put this, so it will be much easier for you to draw this face fact. And then you just the another one where you have, let's say, okay, and that will be easier for you for fact one. Okay, in some cases, the what other type of isomerism, mostly people have written the right answer. So only the answer that uh, this optical word we discourage. So you have to write stereoisomer like this. I mean, stereo term must be there. Otherwise, what optical isomerism will do and anything that is a little bit. I mean, it's not that it is right, but still you should write the stereoisomer. Okay, and the C. So my question is that after giving the question and after I talked to the TA, I am convinced that you people do not have. Let me go back to here. I shall not present it anymore. So that you do not have any idea about the NMR. So if you do not have the idea of NMR, please let me know. I mean, okay, I know that you do not have the idea. So why? I mean, so how many of you, or you please let me know that did you answered it with understanding, or just you got the answer from somewhere and it is correct. Most of the cases it's correct you have given. So if you in assignment, if you feel that yes, it is not the point that we could not understand really that what will be the NMR and how the NMR is affected, then please let me know. I mean, for from next onwards or in quiz also, if you let me know. I mean, this is the advantage of I mean the study here. I mean, in the quiz also, if you feel that all of you that no, this is not the thing that we can understand, let me know. I shall drop that question, right? So it is not that I have given the assignment and you have to write the assignment without understanding. That doesn't give any, I mean, advantage for your studying, right? So please let me know from you the whether it is okay or not, or what is the. Yes, I can do. That is the point. That is the point. Because then I asked the TAs that then how did they write? I mean, they can write clearly that it is, we do not understand this. Then I will understand. I shall drop this one. Was no problem, right? So please speak out that if you do not understand. I have given. I thought okay, I mean, but fluorine NMR, it is really, I mean, not there. And that I shall talk. Let me finish the part today. So, is there anything related to assignment one? So you look at this, and if you have any queries for any particular question, please don't ask it right now. You look at it, and then you either in the group you can write WhatsApp group, or you can mail me, or you can talk to Arithro and Atma, whatever. And this Arithra and Atma, even if you are you ask them if they don't get time because they are also busy. So if I mean, you also drop the question to me also. Whoever will get time, immediately at the earliest will answer you. Okay. So can I start the class now? I mean the next part. And as you can understand that uh, I am repeating things. Uh, I mean, this from the spectra, from the um, this molecular orbital also, so that it goes deep into your uh, thought, that it comes like this, because the many times you listen to it, it will be easier for you to understand. So correlation correlation diagram is the MO diagram, this overlap thing. For every MO you do not need, right? So for every MO I do not need. Okay, let me so there are questions from other students also, so I shall open up the okay, let me do it right now. Fine. Assignment 2. Okay, but I have a problem. So that assignment 2, I have not kept it here. Assignment 2, I directly wrote it in your WeLearn. So we have to open the WeLearn. So let me do one thing. Let me start the class. And at some point when, I mean, today I have kept a little part. Maybe it will take at least 1 hour. Then I shall open the WeLearn and I shall take the question and tell you that what you need to write. Okay. At least give me some yes or no or anything. Okay, let me start. Today again I shall recapitulate something so that it gives you. Okay, so today we'll start with the day 16. 16, right? Okay. So again, so we are in the spectrum. So what are the spectra? Very clearly, you have free ion, then you free ion goes to the octahedral field to the presence of ligand. When we have free ion, we calculated the term this microstates, and as we go to the octahedral field and then we go to the complex, what are the changes that we expect? So we have calculated the microstates, and as I told you, I do not remember whether I kept it in the day 15 slide or not. So again, I have kept it. So if you say that it is not required, you can delete. Or here I kept it just to show you that what are the L is equal to 4, S is equal to 0, what are the terms that are included, because it was time wasting to draw it in the class. And then we have come to the system, that when this is the term, these are the term for free ion, and when you have octahedral field, so we have the separation, that I am not, because last day we have explained all these things. So we have a separation, and as we can expect that spectra, how does it look like? The spectra look like this, and then we have this transition, and we have explained that this transition, if I see here, then this particular transition just account for only one one transition. So it accounts for only one transition, but we are, whenever we have ligand, so free ion, then octahedral field. After octahedral field, we have the real situation where you need the understanding from the Jan Taylor, or what happens if EG has two. So from T to G, it can go to one of the EG, it can go to the other EG. Is there any difference? Yes, there is difference, and that difference is too close, and you cannot expect for that energy anything like that. No, you cannot expect. You what you can expect very close to points, and that are the spectra becomes broader. So as you can understand that if someone asks you to show the difference between the uh, this difference, then it is very difficult for you to this difference. So if it is T2G, if it is EG, and if someone says that what is the difference, so you have to draw. I mean, it is very difficult because where you will do. I mean, it is the actually the spectra like this, and it is the spectra like this. So these two energy difference. So you, I mean, if you draw it in that way, so it is very difficult. I mean, practicality, but you can explain it. Now the second is that, so if we take this D1, it is similar to, I mean, this whole with a D4, and this D6 and D9, and I can understand that all of you have understood this, and this is the situation. So depending on this, the transition will be like this. So depending on the system. Now if we have the D2 and D, I mean other system other than D1. So what is the difficulty now? In the difficulty now, what happens that if we take the D1, D4,
Excuse me, ma'am.
yes,
Ma'am, could you please re-explain the Orgel's diagram?
okay, Orgel's diagram, which part?
Ma'am, the above. Uh, ma'am, this
Last,
diagram.
last
Ma'am, ma'am, from this diagram, I am not able to interpret the message from the diagram. Please help me to
okay, so the point is that, so point is that you have taken the D1, right? D1, and then D1 is what is the term for D1? 2D, right? So first you have to let me. I shall suggest you to go to the last day's class, but I shall explain it a little. Okay, fine. So you have D1. Now first you take the free ion, and then from free ion you calculate the microstate. Okay, did you understand up to this? If you not, you just follow
yes,
this
ma'am.
one.
Ma'am,
2D.
ma'am,
Okay,
up
so
to this I
now,
understand, ma'am.
okay, okay. Every time you say yes, okay, I shall ask. Okay, now it is 2D. Now you have put it in the octahedral field. So how it will feel? So it will come as 2D, as D1 system is T2G and EG, right? So, and the transition is it is written generally in that way. I do not know why. I mean, for understanding, I mean, it is convention. Now this is the T2G. This is the D1 system. Now if you take D4 system, and here one point you must understand that whether it is weak field or it is strong field, the differences will change, right? What will happen? So if you have 2D here, then it is going like this. So if the increase in ligand field strength, right? So if you have a strong field ligand, what could happen? It could increase here. But the transition is definitely T2G to EG. So that there is no controversy, right? So D1. So now D1 system you can 2D and ligand field, it is energy, so it is like this. Now if you have D4, what happens? So 1, 2, 3, 4. So the system is that you have a hole, and now you think that hole is D1. And if you do the term, then you will get that term is 5D. This D is based on this whole, and for that reason it inverts. So if it is inverse, then EG comes lower and P2G goes above, and you get this value. For D1, sorry.
Ma'am, the part I didn't understand, why does it inverse?
Just a minute. This is D1 octahedral, and it is T2G to EG, right? Coming to the point. D1 octahedral and D4 octahedral. Okay. Here you just see that spin multiplicity. When you are taking about the spin multiplicity, then you are taking the number of electron and it becomes 5. Is it clear? But
Yes, ma'am.
when you are coming to this D term, then you are considering that D1, but this one is a whole, because it is, see, the Orgel diagram, they have tried to make it easier to understand, right? So if you have the whole, the reality there is whole is not a concept. I mean, in reality, whole means nothing is there. So if you do it very quickly, then this D term comes from this hole. Hole means this one electron. And as this hole is not present, actually there is present is the D4 system. And from another point you can get it, it is from the symmetry things. I shall try to show it from the symmetry things, but it is, they are also, they say in that way. So as it is a hole, as it is not electron, so it goes, it just reverts in that way. If you just go and if you just go to the D4 system with the 4 electron, it is extremely complicated. I mean, the microstate, as you can understand, the what is the number of microstate, and from this microstate, if you want to find all these uh, like ground term and all these things, it becomes extremely difficult. I mean, after D3, if you just get anything from internet from D3, you will see that in D3 only you have 120 microstates, right? And from these 120 microstate, you have to take the this lowest ground state, and then from that to the next one. So in that way, if you go, it is extremely difficult. So for that reason, here this is taken as the D1 system, but as it is not D1, it is D4 system, and it is not existence. For that reason, we just revert. I shall from the way this quantum mechanical perspective, I shall try to understand. I mean, after that this energy system actually changes. For this, I mean, for remembering purpose, is it okay?
Yes, ma'am. Ma'am, it would be helpful if you correlate with the molecular orbital which we have studied from previous classes.
Okay, molecular orbital. Now,
From molecular orbital, we know that there is a transition from T to G to always EG, and that is the delta octahedral. But from here, it is EG to T to G. It to find it difficult to accept.
okay, so okay, let me check it. How can I make you it understandable? Okay, today let me show you just this one, and next day I shall try to find it how to put it in the system, because their system is D4. Okay, I shall come back. Okay, now I have to deduce it, and it will take time. I shall remember, or you just drop one mail with this question. I shall remember. I shall explain it. Okay. Right now is difficult, a little bit difficult, because you have to find out from where. And in the spectra, actually, it happens with the real system. I shall come to the real system. I shall take an example and I shall explain. Okay. So other than this, is it understandable?
Yes, ma'am.
Okay. So let me go to the next one. The same question. I mean, what happens? it is, I shall tell that day only, maybe next day. Okay, so next is that here also the same question you can ask, that this D2 octahedral. So only one thing I shall tell you from the molecular orbital, that when this symmetry related terms are used, it always not that T2G correspond to T2G like this. Okay, it is what is happen, it takes that what is the ground. Let's say in D2, as we have shown you, that we have two systems, T2G0 EG, sorry, it will give a part answer to your question. Then we have T2G1 EG1, and you have T2G0 EG2. So do you remember from last day?
Yes, ma'am.
Now, then what we have done, we have given this configuration to A2G. We have given these two configuration possible, two configuration to these two, right? And we have given this configuration to this one for D2 system. And here when you are writing, here you, if you just see, if you take D3, then you have E2G3 EG0, E2G2 EG1. So it will have two terms because it will go to one of the EG, right? And then you have E2G1 EG2. This will have one because it's singly occupied. And then you have T2G EG3, right? So you have now three different terms, four different terms, and then you have, you, I mean, as you can understand, these terms then become symmetrical because this is that, I mean, just I'm trying, so it becomes T2, no, I shall not write here in that way, because this T2G3 is symmetrical, and if it is symmetrical, it goes to A G system. A system is the symmetrical system, and if you go here, so if you go here, then D1. So okay, T1 I shall show. T1 is a little bit different because it's also symmetrical. It is not symmetrical. Both of them are not symmetrical. So here it goes to the here, and these correspond to this term. So this symmetry related correspondence become different. So and there is concept of, I mean, it comes like this: when you have T2G2, then is T2G into T2G, and it follows the order uh, that where it will come, and from that the term symbols come according to symmetry related. So I shall not explain, but I shall give you the steps from where it comes. Okay. So it's not that that easily corresponding to T2G or EG2, capital T2G and capital EG. And for that reason happens, and how does it come? I shall give you this calculation and this symmetry relation. Okay, so let us go to the next. So exactly D2 octahedral, and it reverses for this D2 tetrahedral and D3 octahedral. So it all are symmetry related. So let me show you these things afterwards. So if now you have this, so there is another point will come, that what is the del zero? That is again the del zero depends on the which term. I mean, you have what transition you really have. And here if we see, then this for D2 term, the del zero is from T3 T2. So what are the transition possible now? The transition possible are three transition are possible, and from these three transition, this transition is the del zero. And if you have D8 terms, then you have this 3A2G to 3T2G. That term is the del zero, though you have three. So we will do the practical problems, and then we will see that how do we take the del zero. From there we will come to the calculation. Just now this is for information, right? And now if we take the 3F term, so if now we take this del octahedral, then we have seen this energy diagram. This is the del octahedral, and this is a total of 0.8 octahedral. And this, okay, the point is that what this says, that now you have come from free ion two octahedral, and then we are slowly taking the consideration of the presence, will take presence of ligand. So we have come to up to this, up to here we have come to this, that when it put in the octahedral, how does the energy changes, because there is a splitting, and this splitting changes the energy like this. And when what will happen in the presence of ligand? So the presence of ligand, once the ligand come to the system, then let me explain it. You do not have to remember all these values and all these things. There will not be any question from that. But what you have to understand, that what are the things that what are the factors that actually uh, uh, play. So you have inter-electronic repulsions. The point is that once the ligand comes, there are, even as I was telling, that here a little bit of this, once you have the octahedral field, you means that you have put in the metal. And in metal also you have the electrons, and you have the inter-electronic repulsions. And then when you are giving the ligand, then these inter-electronic repulsions becomes more. So now if we take, for example, what I kept it here, it is the uh, P2. So what are the inter-electronic repulsions that uh, that that uh, that how do you, how do you take it, think of it? So you have two electrons in the orbitals. So what are the parameters that defines that electron in that orbital? So these are the uh, position of this. So there is a radial, this part of the wave function, and there is a angular part of the wave function, right? So if you, let's say, take an electron, then it is in the orbital. And how would you define it? You have a radial part of the wave function, and you have an angular part of the wave function. Now, if I took these two parts, then if you take a particular P, then this radial part is same for P. I mean, for both the electron in the P orbital, the radial part of the wave function is same. So where does it change? The change is in the angular part. And here, I what I'm telling, please don't try to understand the exact terms, what is f0, what is f2, I am not explaining, and I cannot explain it in that way also, because it is really beyond this course as well as beyond this, this explanation, because this takes a huge amount of calculation. So then there are uh, two angular parameters, and then they use these two terms, and mainly this f0 and f2, and the scientist who have done this is Slater, short. So there is a huge calculation. So we will come to our point. We are not really interested to do all this calculation over here. So it means that there is a inter electronic repulsion, and that repulsion gives rise to some uh, differences in the angular part of the wave function, and this repulsion depends on these parameters. That is the point that we will understand from that. And then this term Raka parameter comes, and if I take this Raka parameter, that has taken only the two term, that is the B and C. So how does it changes? So these parameters, taking this f0, f2 and all these things, so these parameters they have taken, so they have taken that, so this one you just do not remember now. So taken the parameter, and you, they have seen that the between the 3p and 3f level, if these, so all these parameters from f4, these things summarizes to bc parameter, and then this parameter is given, this is corresponds to this Raka parameter of b and c, abc actually they have taken some leveling effect, because in all the cases A is there. So the most important, this VD spectra is the energy of transition between states having same spin multiplicity. So as you can see that, okay, I shall come later. And here are the terms are there. If you just want to see, any one of you want to see, then you will see that. So so there are terms, just for if you want, anyone of you want to see, you can see. So these, all these parameters f0, f2, all these things, that is from quantum mechanical calculation. So we have come to these parameters. So these parameters reflects that inter electronic repulsion. And what does it do? So what does it do? So from free ion states were there, when it is in the octahedral field, then the actual energy can be given, and the ordering found to be this. And now it is in presence of octahedral field, ligand, everything. So now the thing is like this. So this is the term. Now for this uh, for this electronic transition, we have the selection rule. So what are the selection rule? Laporte selection rule and spin selection rule. Now as you understand that DD transition is Laporte forbidden. So whatever term we take, 3F, 3P, 1G, 1D, 1S, whatever term we take, all of them are calculated based on DD transition. So all of them are Laporte forbidden. So if all of them are Laporte forbidden, and then we consider that all the spin, uh, so now we left with the spin selection rule. So what transition we are interested? Then only the spin allowed transition. So out of these, all transition can happen from 3F to 3P, 3F to 1D, 3F to 1D, 3F to 1N. But as you can understand, only these two are spin allowed. And we are, because in that case we can see some color because it is not Laporte forbidden and spin forbidden, so it is spin allowed. Number two is that if we are sure that we'll take these two things, then there is no C term, and also these we can see as the leveling effect, right? So in that case, we get rid of the term A and we get rid of the term C. Now, if you just do that, what is the energy difference between this P and F terms? Then it is just 15B. So 15B is the term in between the 3P and 3F. But things are not that easy. I mean, it is not easy that you just put it in the well. So I shall explain one thing afterwards. I will just mention it here, that if I go on calculation, then I see. So what do you expect? Now just give me one answer. I in chat also you can write that we are uh, uh, we are giving too much importance. We are giving too much importance to this. So we are giving too much importance to the term free ion. We are giving too much importance in the term that in presence of octahedral field, giving the point in presence of uh, ligand. So what do you expect that the B in the free ion, if we calculate according to this 3p 3f, so once you have free ion, you have the term 3f 3p. Once you have the octahedral field, these 3f terms again uh, uh, give rise to three different states. And then it is in the free ion, and in the complex, if there are metal ligand complex, will the B term will remain the same? So what is your concept? I think you have read it, but still you just try to tell me in terms of that, the way we are trying to understand. The first question is that will the B term will remain the same in the free ion and in the complex? Quick. Will the term B term will remain same for free ion and in the complex? Are you people
No,
there?
ma'am.
Yes. What?
Basically, no. There will be difference.
So yes. Tell me what it was right. So what is the point?
Ma'am, basically, when the metals are in the free state, there is no interaction between the free state. They have a original term symbols, and when they interact with the ligand, there is a change in the changes occurred
Okay.
because of the
Fine.
in the
Fine. This
angular
is the
part.
answer. So it changes. So fine, and correct answer. So your answer is correct. So B will not remain the same. Now, what I want to get it from you, that how does it change, that you can deduce. So what happens? As you said that angular part changes. So my point is that when you are speaking, I'm learning the spectra, when you are learning the molecular orbital, just do not think in the term of, you can think in the term of angular wave function, but practically what happens? Practically, so once the ligand comes, what happens? So electronic repulsion, will it increase or decrease? So it means that change in the angular part means we have corresponded it in the term of interelectronic repulsion, right? So what will happen? Interelectronic repulsion will increase or decrease? Second question.
Increase.
Interelectron repulsion will increase. Okay, so this is any other answer? Any other answer? Please say something. What you feel? I mean, what do you feel? Then if you feel wrong, then you can correct it, and if you feel right, then you can understand. Okay, it was right. I mean, don't be ashamed. You can tell. So what will happen to Sumit has told answer? Okay, fine. Then next, do you agree with Sumit or you do not agree with Sumit? Please interact. It will be better for you. So if I ask question, people are leaving the meeting or their internet may be problem. So what is your okay, Sumit? So it's good. I mean, thank you that at least you have tried to answer. Your point was that there will be change in the angular part. Fine. Yes, it will be changed. But once you have the ligand part actually decreases, the interelectronic repulsion decreases, as you can understand that why does it want to make the complex? Because every system wants to be at a state of a little bit relaxed, right? I mean, if you do not think in term of energy, but if you think every system in the want to stabilize. So if there is the inter-electronic repulsion, once the ligand comes, it can spread. It is not the ionic repulsion. It is the covalency that I mean, even if we are telling it's coordinate bond, but as you can see in terms of there is a overlap between the uh, electron density, and once it overlap, it be relaxed system, right? So in all cases it is not done, and this is reflected that if you have excess energy and if you have pi star acceptor, it gives back to this energy even if the bond length decreases, but it gives back to the energy. What does it mean? That it relaxes. So once you have a metal atom in gas phase, and because in the gas phase only it can be what we are telling is that M plus, otherwise once you put it in any solvent it becomes MH2O whole 6, right? So you cannot compare. So once you have in M plus and you have this changes, then you once you put it in the uh, feel I mean once you have the complex where you have the ligands, the interelectronic repulsion actually changes, actually decreases, and this decrease is solely very much dependent on the nature of the ligand, that how uh, the covalent overlap is increasing. I mean, the covalent overlap, as the covalent overlap increases, the value of B actually decreases. Right? So, first you take the idea, then you try to understand the idea. Okay, now let us see. So, this is 15B. So, one thing I have kept here, probably no, this X factor I have not given. So once this is the in the free ion, and if we put it in this case, can you see this one? Otherwise I shall take one out of the system. Can you see this diagram properly?
Ma'am, it would be better if you take one at a time.
Okay, let me take. So this is a diagram for this is a diagram for D2. Now that you have see what changes I have kept, not I have, but this is. So here you have this term, this 0.2 or del octahedral 0.6 and then del octahedral. And here you can see that we have taken a term X, that is for the repulsion, because these two are the same term and they fill the repulsion. And this will be reflected in, again I shall again come to the Tanabe Sugana, this will be reflected at the as the total thing. So this is only orgal diagram we are taking. I mean, if we put it orgal, so we have put a this gives the a little bit of measure related to measure of interelectronic repulsion. Okay. Now 15B. So next, let us see these values. This you don't have to remember, but you can see that these are the values. So we are concerned about these two things. And as you can see that we are not considering, I mean, D is in between. Even if D is in between, we are not considering this D transition because it is spin forbidden. So we are not considering this 3F to 1D as it is spin forbidden. And also in presence of the ligand it changes, right? And what we do, you just take this value A to leave. So it is general for everyone, A is there, so we can just leave that, right, a little bit, so that it takes care of the all the system. And then we relate the system like this. Now that what I have told you, that the B for free ion is typically greater than B for the same ion in the coordination complex, and related to how much more volume of the valence electron can access the complex relative to the free ion, and definitely that is correlated with the ionic radius, and electrons will experience less repulsion if they occupy more volume. In this regard, this decrease in B is between free ion is to access the degree of covalency in the metal ligand bonds. This is very important. So how would you see? I mean, every time would you go to a list of energy diagram and what is the difference in the energy? How does the B from this F0, F2, F4? Will you come to see the value of B, calculation of B? No. You just see the degree of valence. And how would you understand? You know a metal, you know a ligand, you know that whether it is pi acceptor, whether it is only sigma donor, only sigma donor and pi acceptor. And from that you can understand. So two ways. One is that you just see the B dash value from the calculation. You will have B dash value. Let's say you have a cobalt H2O whole 6 2 plus system. You would see the V dash value, and you have a cobalt NH3 whole 6 2 plus, and you just see the B dash value. So you can come from this B dash value, you can see that what is more covalent, and you can correlate, or from this NH3 ligand and H2O water ligand, you can go back to the B dash value. We will keep some time classes to show all these problems, right? So let me finish, and I shall of course answer this symmetry aspect and this one. So we can from this Raka parameter. So once you change it, so you have a two term, right? You have two term, and this B test. So B test is in the free ion and this is in complex. So I shall come back to the Tanabe Sugano. Let me just show you this. So this is called the nasal oxidation effect. So this Nephelauxetic, what is the term means? This term means the cloud expansion. Right, so this electron, you just read it. So I have explained everything, and this is, and as you can understand, if B is less than B, then of course beta is less than 1. This is very simple in that way, and you can find that what is the ligands order for this nephelauxetic series. So a large, the small value indicates the large measure of d electron. Uh, this delocalization shall come, and there are some calculation as well. Okay, now let us go a little bit to understand what is the time. Okay, as I told you earlier. So now this Orgel diagram. So this Orgel diagram, if you go for D1 system, you do not have any problem. D1 to D2, D2, D1, D4, D7, you do not have problem. But here you do have a problem. See, here it is the only the measure of ligand field increases, right? But what is the value? No value as such is there. Every time you have to take this del value, and also the B has not been considered in Orgel diagram. So for weak field ligand, Orgel diagram is fine. I mean, it is much easier. Tanamisogan is also there. So we have to deduce something, the TS diagram. So what we will take, this Tanabe-Sugano diagram is the correlation diagram that will take care of the inter-electronic repulsion within the graph. So what people have tried, so you know that from the spectra, what do you know? What are the energy difference? So if you have A2G and if you have a T2G, so you know that the energy. So it is the term that is known to you, right? So they have taken the E by V, and in the y-axis they have put E by V. So this is the y-axis, they have put the E by V. If you have the del 0 value divided by B, so this del 0 by V from the calculation, all the calculation they have done, and then you have this B15B, where from it get, so from these differences they get it is 15B. So accordingly they take the value of B. So here if you and one of the most important thing is that they put the lowest energy in the x-axis only. So put the lowest energy as x-axis so that you can give the diagram. Now here we, let's say you have a energy 3 transmission. Energy E1, E2, E3. So initially you have not been told whether it is a weak field ligand, whether it is a strong field ligand, whether it is in the midway, or you do not know initially. So if you see, then you can see that for this term and for left of this part is E1, E2, E3. So from T3, T1 to 3 to 2, T1 is the highest energy term, right? So you can, according to whatever value is there, so you will put that this is the highest energy, this is the next one, and the smallest one you will put it here. Once you have it there, once you are here, then you can see this is the lowest energy, this is the next energy, and this is the highest energy. So once you have a strong field ligand, then the highest energy you will put 3T1 to 3A2, and you have this part that what is del, del is T2 to T2G2 to A2G. So here you have this value for del, and here you have this value for del. So now, seeing this del zero value, you can also understand. I mean, from definitely del zero value is a reflection of the strong field ligand, but this del zero by B value, it is for to take care of the B. I mean, then you do not have the problem with the B, and you do not have to keep these X or all these things for considering the interelectronic repulsion in Orger diagram. Otherwise, if you have these three values, okay, another thing I must say, that if you have these three values, three unknown, so del oct unknown, B unknown, and X unknown. Now, if you have a system where you expect three transition, then if the three transition all you can see properly, like, and you can find out three unknown. But if you just see the spectra like these, then it is very difficult for you to consider, because 2 point you will get and three unknown, you cannot do that. But that problem has been taken care of by this parameter. How do we do the calculation? We'll, with the example we'll see. And so we interpret the Tanabe-Sugano diagram. Now here in that context, let me tell you one thing, that if you have the from the free ion, when we are going to the complex, so what are the things? Number one is the, just a minute. Number one is the electron-electron repulsion. I mean, or either in free ion or in complex. So, electron-electron repulsion. And we have taken care it in the spectroscopic term. I can put a new page. So, electron repulsion. So we have taken care it spectroscopic term. Then octahedral the ligand field. Ligand field, we have taken the spectroscopic term. Then you have the spin orbit coupling. You have taken in the spin multiplicity. You have spin coupling. You have spin coupling. That we will take care in magnetic state. Then we have hyperfine coupling, that we will take in the, then we have the Zeeman effect. Zeeman effect we have in the magnetic. Here, these three things will be taken care by magnetism and EPR spectra. And we are interested in these three. This is just for information, I forgot. So, in the spectra, electronic spectra. Right. Now, so after a delete. So now this Tanabe-Sugano diagram and interpretation. So usually interpreting the Tanabe-Sugano diagram, so what we see, number of bands, band energies, intensity. If intensity, how do you see? If we take the solution, then we say it is in the epsilon value, and here is the concentration, and then you have the breadth and the shape. So we say that it is overlap of two orbitals, two transition or not there. So these are the electronic spectra we just see. And then why do you need? So we need that, what I have explained. I have explained all this term, that we need to consider this energy as well as the B as well as the octahedral field. So if we want to put everything on the diagram, so everything will be taken care of the diagram, in one diagram. We really cannot do it in the orgel, and we have to go to the TS. And then why this TS? Because Tanaveshinaga, and another thing, that if we see the orgel, we have taken only the spin allowed transition like 3F and 3P. We do not put these other things, but we must know that where is the uh, other energy systems or spin forbidden transition. Even if it is there, what if someone asks you what is the spin forbidden transition, uh, I mean, what are the states that it will do, or some other. So there you can also tell that what are the spin forbidden transitions. So it takes care of all the states that arises from the free ion, and then it put it in the diagram. So the energy system can be, once you see this figure, you can easily understand that what happens when the system puts in the ligand field. And I mean, in octahedral or tetrahedral field basically, and you can change a little bit of this with along with the ligand also, because weak field and strong field, once we say, we take care of the ligand also. So while we will go to the spin forbidden transition, what is the position of the states now in the presence of weak field and strong field, and it is very easier to understand. So if we take that E by B value and then delta by B value, so you can put these values from here. This is the basic thing, and then you can look at this and you can assign the transition. I have kept some transition like this. So this is the D2 case, this is the D3 case, and once you have the D4 case, D5, everything you can put. So you have only this E and T2G transition, that is that the transition will take place, but it can show all the terms over there. Like you can see here. Okay, then today I shall not explain your answer. I shall come with all these things. So these are the problems that you can see. What is the 10 DQ? What is the band? So I shall explain. I shall do. We shall do together. You please read it, and we shall do together all the these problems. How to deal with the problems and all this thing. So is it a little bit understandable now? So this is the whole story. At least we could, other than charge transfer, we can have the whole story now, and it will take a little bit time to tell you. And now we have a little time, so I shall go to the assignment too. But before that, let us fix the syllabus for the assignment this mid sem. You please tell me. I mean, would you like to allow me to take questions, not with the problems, but other than these, or would you like to fix it till the whatever you have learned till Tuesday? I am taking this assignment too.
Ma'am, we would like it to be till Tuesday.
Tuesday, okay. So let me show you the assignment 2 and tell you what to do. Okay. So the first was is the ML6 octahedral with sigma and pi interaction. That I expect the full interaction with all these orbital overlap, not only overlap with metal D, S, P and ligand orbital. You can draw the structure by copying from the book, but you have to understand. My point is that you can copy, but in every time you are drawing an orbital, try to understand. And if you do not understand, just ask me that why it is happening. And it is preferably you draw the structure like this. Either you can put it like this to show the sign of the orbital, or you can put it in different color, whatever, but you can see and you can draw, but you have to understand each and every step. And if any one of the step you do not understand, please let us know. Clear?
Okay,
But
ma'am.
email, okay, email for square, this is optional in some textbook with all the pi this ligand pi interaction is there. So if you want, you can draw, or if you do not want, you can only give the d orbital metal picture.
Excuse me, ma'am.
Yes,
In case of the first one, in case of the pi interaction, we need to draw the full emo diagram for separately for,
yes, full hemodiagram. This one is full hemodiagram.
I mean for pi donor and pi
Yes,
acceptor.
pi donor and pi.
We need to draw the full emo diagram for this
Yes.
one
So
also.
if you do not find, let me know. Okay.
Okay, okay, ma'am.
And then this is only d orbital with overlap. Okay. Only d orbital with overlap. You have to show that what is going where, which orbital, like as I have shown you like this. So here, from here the ligand is coming, and here you have the dx2y2, right? These things you have to show that what orbital is overlapping, where somewhere it is anti-bonding, somewhere it is bonding. So these things you must be very clear. It is not for me, it is for you to understand. And here what I have shown you at the last day, I mean, like overlap of this, how the pi pi overlap takes place, this sigma sigma and this delta delta. Is it clear?
Yes, ma'am.
Okay. So please response that how do you, I mean, every time I come and I tell you something, so how do you feel the course? I mean, do you think the pace is right, or do you think I must be slow, or whether you are understanding the things or not, or from one class to another class, can you follow this? Please let me know. Some you give feedback to the institute, that is something different, right? But if you give me the feedback, but as you can understand that as you people are also facing problem for this online, we are also not used to do this online for a long time or something, right? So please give some feedback that it's okay. I mean, it cannot be perfect, but we can improve, so that we can improve, right? So please give something. I mean, whatever you feel, please tell something.
Ma'am, from this part, if you bit slow down, it would be better.
Yeah,
From
I am
Tanave
trying.
Subano part.
That is every day I am repeating, right? So what I expect, fine, it is very good. So what I expect that last day, whatever I told, today when I have told, it must be clear, or you can understand that I have not understood this. So today I told you the nephroleptic and this Tanabe Sugano. I shall. But the point is that what I shall do, that nephaloxetine and tanabesugano, next day I shall take. I mean, this after exam the class will be there, right?
Yes, ma'am.
I think the class will be after the mid-sem, right? Or will there be any class
Ma'am, after the mid-sem.
after the mid-sem? So what we will do, uh, apart from that, what you have asked, that is the different question. First, I shall give you the explanation in PowerPoint, and then whatever the point is to explain, I shall explain. But other than this, we'll take real examples, right? Then we'll put the first we'll try to understand the nephaloxatic effect. So nephaloxatic effect is a little bit of difference. So this B part we will understand that how the breath is changing, and then for spectra for Tanabe Sugano we will take some more this problems, and then we will put the things. Okay, any other thing that you, any other suggestion or feedback? So there is no suggestion. I really don't understand whether no suggestion means positive or negative. So Aritra, is there any suggestion? Isha, Anusha?
No, ma'am, no more suggestions. The pacing and all is fine.
Okay. Okay, so I mean, again and again, as I am telling you, and now I have shared the number of the TAs also. So if you at I mean, even if at midnight, if you are studying it, if you have any question, just drop the question. Maybe at that particular time we may not answer you, but we must know what are the difficulties that you are facing during the study, right? So please let us know. Okay, thank you. And you can stay.